All right, class. Welcome back from spring break. I hope you guys all enjoyed a little bit of time away from your computers, but also I hope if you were bored, you took a look at some of those contests that I uploaded. If you did do those and you want to show off your results, feel free to share those with me. I'm always curious to see how you guys are doing on stuff like that. Um, but for today, I thought we'd actually transition a little bit from the work we've been doing. So before spring break, we've been talking a lot about quadratic functions. And we looked at different ways that we could sketch graphs of those using either completing the square, factoring, or the quadratic formula to find the x-intercepts. We also could rearrange it and put it in graphing form using the completing the square method, and that would tell us the vertex. There were other methods to get the vertex. We could get the y-intercept, and we could sketch those graphs. So that was a big focus of ours for actually a long time now. You have videos on all of those topics I just mentioned if you need any review. But now it's time for us to transition to a bit of a different topic on inequalities. And I think some of you might be excited because inequalities are something you've studied in the past. This video is actually going to be hopefully a little bit of review for you, but also a great chance to brush up on some of these things. So let's talk a little bit about a simple equation like x plus 5 is equal to 9. So if I asked you guys to solve for x, I'm hoping there wouldn't be a whole lot of hesitation. You guys would all know to use inverse operations to subtract 5 from each side, and then you'd be left with x is equal to 4. And we're all happy there because at that point we get our final answer and we're done with the problem. But let's make one small change and see what happens here. So all of a sudden, instead of looking at x plus 5 is equal to 9, let's go back in time. Let's say that x plus 5 is greater than 9. So think about that. How does that change this problem? Will you just get one answer anymore? Meaning, is there one value for x that makes this true and that's it? That was the case when it was x plus 5 is equal to 9. We knew right away x had to be 4. But here, if I want a number greater than 9, I could put 5 in for x, and that would give me 10, which is greater than 9. Let's look at that. 5 plus 5 is greater than 9. 10 is greater than 9. I think we'll all agree on that. Where it gets tricky, well, it turns out I could also put 6 in for x. And that would be true as well. 11 is definitely greater than 9. And even trickier than that, I could put in 6.5. I could put in 6.75. I could actually put in an infinite number of values for x that would make this inequality true. So to represent our solution here, it gets a little bit tricky if we try to just write it out. There are a few ways we can do it though. So x plus 5 is greater than 9. Let's think about what is the smallest value of x that makes that true. And to do that, we're going to want to find what's called a boundary point. So we'll start out using inverse operations just like we would if it were an equation. So I'll subtract 5 and I'll see that 9 minus 5 is 4. I know x can't be equal to 4 because if I put 4 in for x into my original inequality, that would say 9 is greater than 9, which isn't true. So I don't write x is equal to 4, but you know what? What if x was greater than 4? If x is greater than 4, that means I plug in 4.1 or 4.01 or 4.001 or any value greater than 4, and all of a sudden when I add that to 5, it better be greater than 9. That is true here. So I can represent all the values that'll make this inequality true by writing x is greater than 4. Another way that I can show that would be on a number line. So if I sketch, let me get a straight edge here. If I sketch a number line, and I look at, all right, let's say this is 0, 2, 4. Just to show we've got negatives as well. Here's -2. So we'll look right at 4, and that's where we begin our boundary point. Since our answer can't include 4, we'll use an open circle to identify that. Let me do a better open circle than that. So an open circle to identify that we can be really, really close to 4, but our answers can't include 4 because that doesn't make our original inequality true. And then because we said x is greater than 4, we want to go towards the numbers that are greater than 4, which would include like 6 and 8. So we'll draw an arrow and a line on top going to the right, which shows that the x values are greater. So that's a way to represent the solution set. Another thing you can do, if you ever get to the point where you've identified the boundary point and you don't know which way to draw your arrow, do you draw it to the right or left, is to pick a test point. So you can say, well, let's see, does 0 make this true? So 0 plus 5 is greater than 9. That means 5 is greater than 9. That's not true. So I don't want to be over top 0. I don't want to go that way. I want to go away from 0 because that's what made it true. Right now that might seem like an excessive step to pick that test point because this was a straightforward problem. But there are times where you may see that things change and are a little bit unexpected. So let's take a look at another one of these and see if we get a different outcome than we would expect. How about we erase our work. And look at a different equation. So now let's look at negative 2x plus 4. And let's say that is less than 12. Actually, let's call it less than or equal to so we can get another look at an example here. So working with this, again, it's not obvious right away what values for x should go in, but we can solve it like an equation to get that boundary point, or the point where we know that one side of the values will be true and the other side will make that equation or that inequality false. So to do that, we just use regular inverse operations. So we'll subtract 4 first, and we'll see that negative 2x, we'll call it less than or equal to 8, and then we'll divide by negative 2 on each side. And if we just bring everything straight down, it would look something like that. And you'd say, okay, x is less than or equal to negative 4. I'm done. Same thing, we're going to put that on a number line. Let's call that 0. We're going to the negatives. There's negative 2, negative 4, negative 6. So on my number line, I identify, okay, where's my boundary point? Negative 4. This time, since it's not only an inequality, but it includes equal to, I'll put a full shaded in circle there. And then since it says x is less than or equal to negative 4, originally I'm tempted to just draw an arrow to the left and say, okay, problem solved, I'm done, I'm happy. That's where my answers are. But I really do need to use that test point idea. So if I go back and I say, okay, well, I know the boundary point is negative 4, meaning that's where the change happens. What if I pick 0 and see if it's true or not? So what if I solve negative 2 multiplied by 0 plus 4 is less than or equal to 12? Well, negative 2 times 0 is 0, plus 4 is less than or equal to 12, so 4 is less than or equal to 12. Did that work? Is 4 less than or equal to 12? The answer is yes, that is correct, which is tricky because 0 is to the right side of my point on the number line. So if you look at the number line, I'm drawing my arrow now. 0 made that true, So I need to have my arrow going over top of 0. What that means is that my inequality actually has changed. So it's not x is less than or equal to negative 4. X is greater than or equal to negative 4. That was an unexpected result that we found out by using our test point to see what values would be true. And that's something that happens because we divided by a negative on both sides. If we divide or multiply by a negative, you'll see that your inequality flips from less than to greater than or greater than to less than. And so we need to be really careful and use a test point. You may have noticed I picked 0 again for my test point, and that's because I want this to be as easy as possible. 0 is an easy number to work with, and so right away I could plug it in. I showed my steps, but honestly I probably didn't even need to know if that would be true or not. And since 0 made it true, I shaded right away with my arrow going over top of 0, and that let me know to change that inequality. So that's how we'll work with these. There are some great examples for you to try when you go into your ebook. For this, we'll be in lesson 9.2.1, and we're not going to do the lesson, just the review and preview, so 950 to 955. That'll be your homework today. When you're done, take a picture and submit it like you have been. I've also included the answer key so you can check your work. And if you have any questions, see me during office hours from 9 to 11. Just add a quick private comment on Google Classroom and I'll get back to you in real time. All right, guys, good luck with the assignment and let me know if you have any questions.